Okay, you guys, today is exciting because we are going to learn how to do synthetic division. You guys are going to be so happy about this, I think, seriously. Now, I'm going to show you, I just emailed you out the answer key for the last homework and me working out a few of the problems. In fact, this exact problem is the one I worked out on the last video. I left it here for a reason, because I'm going to show you now how we can do this thing a different way. We did, this is number 9 from your homework, from your last homework. I think it was 45, right? We did number 9. This is it. We came up with 2s squared minus 8s plus 3 plus 1 over s plus 4. You can watch me in the previous video. I worked this out exactly and showed you where it came from. Okay, let me show you something now called synthetic division. I'm going to solve the same problem a different way, not using long division, using something called synthetic division. This is how it works. Now, synthetic division is super duper easy, but it is very strange and it is very, may not make any sense. So you really need to pay attention to me when I explain it to you, because it's not hard. You're gonna be amazed how easy it is, but you probably won't understand why it works, because I don't even understand why it works, but it does work, and it makes it's an easier way to do these problems and a bunch of the other problems. It's an easier way to do some of the long division problems, and it saves you from having to do long division. So what you need to do is pay very good attention to me when I'm explaining this, because it needs to be explained. It's probably not something you'll figure out on your own. So here goes. I'm going to explain it. Here's how synthetic division works. I have this polynomial, or no, actually over here. It was this polynomial divided by this polynomial. It's number 9 from your homework. 2s to the third minus 29s plus 13 divided by s plus 4. Okay, so you take the thing that it's being divided by, the bottom thing, like the thing on there, s plus 4, and you say, what value of s would it take to make that thing equal 0? In other words, what root goes with the factor of s plus 4? What value of s can I plug in there to make that equal 0? Well, it's going to be -4. Remember, it's just opposite of this number, basically. If this is s plus 4, it's going to be -4. If it was s minus 4, it would be +4. You basically change the sign. That's how it works. So in this case, I'm going to use -4. So here we go, -4. Then you put this little backwards L thing. Don't ask me why, just do it, okay? Backwards L thing. Then you look at your coefficients of the numerator part, or the inside guy here. Coefficients. Now this is super important. You need to make sure and account for every zero for every missing term. Third power, there was no second power term. I have to put a 0 in there. If I don't put a 0 in there, I'll get what's called the wrong answer, okay? I need 0 in there. Now, with long division, if I were to forget this 0, I probably would realize it, because as soon as I said this needs to be 2s squared and I didn't have anywhere to put that s squared term, I'd say, oh, I forgot the 0s squared. That's not going to happen with synthetic division. If you forget to put in these 0 terms, you're not going to realize it. You're just going to get the wrong answer. So make sure you remember to account for all missing terms with zeros when you do this. So what you do now is write in all the coefficients, the number parts. You do not put in the variable parts. So 2s to the third plus 0s squared is going to be 2, 0. Minus 29s is going to be minus 29. And then plus 13 would be 13. So you just put all the coefficients, all the number parts, okay? And then leave a little space, because we're going to put something right here. Leave a little space, draw a line, and then right before the last guy, you go like that. There is the setup to do synthetic division, okay? Just don't ask me why, just do it. It works, okay? Now, here is the process. Pay good attention. Here's the process. You always bring the first thing down below the line. Whatever number this is, you just, if this is a 2, you put a 2. If this is a 1, you put a 1. Whatever it is, bring it down below the line. And then all you do for the whole rest of the problem is multiply and add. So multiply this times this. 2 times -4 is -8. And you put it under the next guy right here. Now add these together. 0 and -8 is -8. Now multiply. -8 times -4 is regular 32, right? And then add those together. You get 3, and 3 times -4 is -12. We're multiplying. Add those together, 1. You're done. You just did the equivalent of long division. Here's how it works. See this little dot thing here? This side is always the remainder, and then it goes constant, first power, second power. If there's a number here, it'd be third power. These are powers of the variable. Constant, x to the first, or s, this is s in this case, s to the first, s to the second. So, what would the this guy divided by this guy, how would you read this? It's going to be this guy times the variable squared, so 2s squared minus 8s to the first power, plus 3 is the constant, and then 1 is the remainder, so it'd be plus 1 over what we divided by, s plus 4, and oh my gosh! Oh my gosh! Oh my gosh! I can't believe it! Es lo mismo! Oh my gosh! I got the same answer by doing that as doing long division. Can you believe it? Son of a gun. How does that happen? I don't know. But that's it. Would you rather do it this way or this way? I would rather do it this way. Look, do you have to do it both ways? No. One way or the other. I like this way. So let's do a couple more because I know it's a lot to absorb. So let's do these over here. Okay, synthetic division coming here. Blah, 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 divided by x plus 2. So I zero in. X plus 2 is dividing by x plus 2. What is going to be the root that goes with x plus 2? Well, you change the sign, right? It's -2, because look, -2 plus 2 is 0. What does it take to make that 0? -2. That's going to be the root. Backwards L thing, right? Then coefficients, just the number part. 3x to the third, 19x squared, 15x minus 10. Okay? Notice there were no missing terms, so I didn't have to put any zeros. Leave a little space here and go like this. Now, bring the first guy down below the line. 3, like that. And now all you do is multiply and add. 3 times -2 is -6. Add those, 13. Multiply those, -26. Add those, -11. That times that is 22, baby! You know it! And then 12 is the remainder. So we've got, it goes like this. Remember, remainder, constant, first power, second power. So the answer would be 3x, the variable's x squared plus 13x to the first power minus 11 is the constant plus this guy over x plus 2. 12 over x plus 2. And check it out. If you want to, you can try it. If you did long division on this, guess what answer you would come up with if you did it correctly? This guy. See how that works? Now, I've taught this several times. I know people are like, that doesn't seem hard, but sometimes people are still confused by this because it's like a process. It's not something you can just follow and say, that makes a lot of sense. It's just a process you got to learn. So some people have, need to see a few more problems to absorb how to fully do this. So I'm wanting to do a few example problems so that you guys can see how to do this a little better. So, okay, so let's do a couple more. Okay, x plus 1. The root that goes with x plus 1 is a factor. The The root for that factor would be -1. -1 with the backwards L thing. Then you're going to go 3x to the third, 19x squared, 15x minus 1. Notice there still was no missing. I'm always checking to see if there's missing powers because I got to account for them with zeros if there are. But there weren't in this case. Leave a little space. Okay. Now, bring the 3 down below this. Multiply 3. Add those together, 16. Multiply, -16. Add those together, -1. Multiply, 1. Cha-ching, 0. Cha-ching, cha-ching. What does that mean? That means my remainder is 0. That means it goes evenly. Constant, first power, second power. There's no remainder. So the answer here, this guy divided by this guy is just going to be 3x squared plus 16x to the first power minus 1. And there's no remainder, so that is the answer. It divides evenly. Isn't this synthetic division great? Yeah. Way better than long division, I think. Okay, here we go. X minus 5. The root that goes with x minus 5 would be regular 5, positive 5, right? And so let's do these. 1x to the fourth minus 7x to the third plus 14x squared. Wait a minute. There's no x term, so it's going to be 0 and then -20. If you don't put that 0 in, you're going to get the wrong answer. So watch for it. I'm trying to tell you. I'm trying to show you common mistakes people make. Leaving out that 0 is critical, and people make that mistake all the time. So here we go. Bring the first number down below the line. Boom. Multiply. This times this. Boom. Add these together. -7 and 5. -2. Multiply these two. -2 times 5 is -10. Add those together. 4. Multiply. 4 times 5. 20. Add those together. 20. Multiply those. 100, right? And then add those together. 80. So that's the deal. And it's going to be remainder, constant, first power, second power, third power. This one goes all the way up to x to the third. That makes sense because this is a fourth degree divided by a first degree, which would be third. Here we had third divided by first. That knocks it down to a second. So it makes sense. So here's what the answer would look like. 1x to the third minus 2x squared plus 4x to the first plus 20 plus 80 over x minus 5. And believe me, to do that problem, to do that same problem by long division would be not very much fun. But it's really not much of a problem doing it by synthetic division. This is much easier. Let me erase this now because it's going to be in the way of my next problem. Okay. So this guy right here. Okay. X plus 2, right? The root that goes with that is -2. Okay. Then I put 1x to the 4 minus 2x to the third. Uh-oh, there's no x squared term. Don't forget the 0. 13x minus 6. Notice I only put the numbers. I don't put any variables there. And then leave a little space. Okay, now bring down this number below the line. 1. Multiply. -2. Add those together. -2 and -2 is -4. Multiply. -4 times -2 is +8. This plus this is 8. 8 and -2 is -16. 13 and -16 is -3. Multiply those and you get regular 6. This is 0, cha-ching. That means it goes evenly. So we've got remainder, constant, first power, second power, third power. So the great and mighty answer is 1x, wait, is it x? Yes, x, 1x to the third power minus 4x to the second power plus 8x to the first power minus 3. There's no remainder, so that is the answer. Now, I told you last time that long division wasn't the funnest thing, and I was going to show you something way better and way more exciting. And once again, I told the truth, as usual. Okay, so that's the deal. Now, I know what you might be thinking. You might be mad at me because you might be saying, "You, that dirty dog Ferrari made me learn long division when he could have just shown me this to begin with. Why did he make me go through all that misery?" And I say, I can understand that, okay? But here's the answer to that. Here's the problem with that. Here's the bad news about synthetic division. The bad news. It only works sometimes. It doesn't always work. That's the problem, okay? Now, it always works on the type of problems it works on, like these problems. It always gives you the correct answer. But notice what happened with these problems. Notice what I've got. I've got divided by x plus 2, x minus 5, x plus 1, x plus 2. Notice what I don't have in the denominator. Let me write some things that I don't have. X squared minus 2x plus 7. I don't have 3x squared minus 4. I also don't have stuff like 2x plus 5, stuff like that. Notice, I didn't see synthetic division with any of those guys. It's because you don't use synthetic division on them. If I got blah, blah, blah divided by this guy, or this guy, or this guy, then guess how I do it? It's called long division. Do I wish that Ferrari would show me a little nifty, tricky way of doing that? Yeah, I wish. But unfortunately, it doesn't. There is no nifty little tricky way of doing it. You have to do it with long division. So when you run into stuff like this, basically the only ones you can do with synthetic division is when you got your variable. I'll call it x, but it could be y or whatever your other variables are. But x plus something, or y plus something, or y minus something. So basically your variable plus something or variable minus something. If you have a number in front of your variable, forget it. If you have a squared term or higher in the denominator, forget it. It has to be single x plus or minus something for you to use synthetic division. Now, if you read the book actually shows you how to do synthetic division on problems like these. These type of problems can be done with synthetic division if you really know what you're doing, okay? But they're stepped up a significant notch, okay? They're much more difficult than these, and the chances of screwing them up are way more likely than with these kind of problems. In fact, the chances of screwing these kind of problems up with synthetic division is so high that I highly recommend you do not use synthetic division on this. In fact, on tonight's homework, it's gonna say, actually let me go to it and I'll show you. On tonight's homework, there it is, homework 46, page 370, 1 through 9 all, 11, 13, and 15. Now, look what else it says. On 1 through 11, use synthetic division. On 13 and 15, use long division. Because 13 and 15 are like the problems I showed you where there's a number in front of your variable. Now, the book shows you how to use synthetic division on those. If you really, really want to try using synthetic division and teach yourself how to use synthetic division on those, that's fine. But I recommend that you do not. I recommend that you use long division. Even though the book tells you to use synthetic division on 13 and 15, I recommend you use long division. So there you go. Enjoy.